Hello everyone, welcome back. In our today's session, we will have discussion about subnetting. We will try to understand what is subnetting and why we required the subnetting. Okay, let's have a definition of subnetting. Subnetting, a process of creating subnetworks. A process of creating subnetworks mean we will have our main network, we will divide it into subnetworks. So main network will be divided into subnetworks. So how we will do this division? We will do this division using subnetting process. Using subnetting process, okay? Maybe you guys are thinking that why we require to divide this main network into subnetworks, or why we require the subnetting process. Remember guys, the according to default approach, classful approach, okay, or default approach, there are some issues. The first issue is limited number of network addresses and more number of host addresses per network. This is the issues with the classful or default approach. We have limited number of network addresses in IP version 4, and we have more number of host addresses per network. Okay guys, so let's understand both issues in detail. Then we will have more understanding that what is the meaning of creating subnetworks. Limited number of networks in IP version 4. We know this, that in IP version 4 we can only use class A, B, C. Okay, class A from 1.x.x.x. Here only one octet belongs to network, so it is up to 126.x.x.x. Class B start from 128.0.x.x. It is up to 191 dot 191 can let me yes dot 255 dot x dot x. And class C, okay, and this was B, and that was 1. Class C start from 192 to 223.0.0.x up to 255.255.x. okay, and here we can find the number of networks. 126 number of networks are here, and in class B we have here 64 multiplied by 256. That will be the number of networks. in here 32 multiplied by 256 multiplied by 256, so equal to each class number of total networks. Okay, so now for example, let's take the class A. We have total number of networks 126. Okay, yeah, class A, total number of networks and host per network. So class A total number of network is 126. Host per network is 16,777,214. This is the number of host per network of the class A. So now, and come to the class B. Class A, B. Class B. So 64 multiplied by 256. 64 multiplied by 256 is equal to 16,384. So here the number of networks 84. The number of hosts, that is 2 power 16, because here we have x means 2 octets belongs to the host. So that is equal to 65,536 minus 2 34. Okay, in class C the total number of networks is, let me use the calculator, it's equal to 2097152. In number of hosts 256 minus 2, 254. This is the number of hosts in class C. So now let's make a total number of networks in IP address version 4 is equal to 126 plus 16,000, okay, plus 16384 plus 126, it's equal to 2113662. This is the total number of addresses, networks in the class. See, it's very less. It's very less, and worldwide we have more than this number of networks, and each organization network required a unique network address plus a unique set of host addresses on the internet. But you can see here it is very few, so it means we have what issue of limited number of network addresses. It's clear. More number of host addresses per network. You can see here only 3 options available. Class A is giving us this much host, which is in every case more than the organization requirements. Class B is giving us 65,000, very rarely fit to some organization requirements, and 254. So here are only 3 options, or you can say 3 cases, and obviously this is not matched to all the organization requirements. Sometimes it will give us less than the required number of hosts per network, sometimes it will give more number of hosts per network, and sometimes it will give us too much host addresses per network. So it means the default approach, the classful approach, is not matching the requirements. And that's why if we will using, for example, 1 lakh addresses, so obviously we will go for the class A, and in class A we will have what, 16 million, so we will wasting how much? Almost 16 million, okay, or more than 16 million. For example, we need 5,000 IP addresses. We cannot use it in class C, so definitely we will go for the class B. And in class B, we will use what, 60,000, because our requirement is 5 and we are picking the class B networks. It's giving us 65,000. So obviously 5,000 minus 65,000 is equal to 60,534. This much addresses will be wasted. So dear students, this was the main issue, okay, limited number of uh, network addresses and more number of host addresses per network, and the subnetting process get introduced to solve both issues, okay. And now come here. Subnetting was what? A process of creating subnetworks. So a process of creating subnetworks means we will pick one of the network and we will divide it into subnetworks. Let's suppose the class A 10.x.x.x. 10 is what? It's a network. So let's suppose this will be our main network. The 10 will be divided by using what? By using subnetting into what? Into subnetworks. Okay, what will be the logic of this division? It means based on what we will divide it? Based on our requirements, okay. It means based on our requirements we will do this division. Based on our requirements mean what? Like how many subnetworks are required. Okay, how many subnetworks? N. And hosts per subnetwork are required. So how many subnetworks are required and how many hosts per subnetwork is required? So based on this we will do what? We will decide this division process, okay. So this was subnetting, and we understand it that a process of creating subnetworks based on our requirements. Requirements mean how many subnetworks are required or how many hosts per subnetwork is required, okay. Now how we can do this subnetting? Methods of subnetting. There are two methods. The first method, CIDR. The second method is VLSM. CIDR is one of the legacy method, okay. Legacy and inefficient method. This is the new and more efficient method, okay. We will prove it how it's more efficient and how it is inefficient, okay. This is supported by the old router, this is supported by the new routers, okay. Both are actually subnetting. By using both we can divide this, but with the help of VLCM we can further decrease the number of wasted host addresses per network, okay. It means the VLCM support resubnetting of a subnet. It's once we divide a subnet, like main network, like main network divided into subnetworks. This subnetworks can be again divided into subnetworks. Okay, so this is called why we can it's more efficient because it's support resubnetting of a subnet to further decrease the number of host addresses per network. Okay, but don't worry, we will have detailed discussion about CIDR and VLCM. Right now you have just keep in your mind that subnetting have two methods, CIDR and VLCM. Okay, and this was the reason why we need subnetting. This was the problems, limited number of networks and more number of host addresses per network. To solve these problems, we have a solution. That solution is called what? Subnetting. Okay, and it's a process of creating subnetworks. Thank you very much. If you have any question, please let me know in the comment section. And further about CIDR and VLCM, maybe we will have separate lectures about that, and we will understand that by many practical examples and solutions. Thank you very much.